Hi everyone, so today we are going to be looking at the properties of logarithms. Now we're going to be able to evaluate logarithmic expressions as well. So here are the couple properties that we need to kind of keep in mind. Now the product property is if I have a logarithm and I'm multiplying two things in my argument, so in this case A and C, well I could actually split those up and say that those together actually are two different logarithms when I just add them together. Now the base still stay the same, but my argument of that A with the argument of that C, I can actually split those up. When I think about the quotient rule, I can think about the log of a base. And in my argument, I have a fraction. So I can think about that being two different logarithms, same base, but the argument of A and the argument of C are in two different logs, and they're being subtracted from each other. When I think about the power property, I've got the log of a base, and in my argument, I have, let's say, a variable, or I might have a number, and it's raised to a power. So that exponent, when I move it to the front, is going to be a constant multiplied by the logarithm, and the argument is going to stay as that a, which could, again, be a variable, could be a number. Now keep in mind, looking at all these properties, notice that the base never changes. You might split up that logarithm using the product or the quotient property, but notice that that base always stays the same. So we don't want to ever change that base. So now let's use these properties to help us to evaluate certain expressions. Now, when you condense logarithmic expressions into a single logarithm, that allows us to be able to evaluate the expression. So let's go ahead and use the properties of logarithms to help us evaluate an expression. So here we're going to write each expression as a single logarithm first, and then we're going to evaluate. So here, my first example, I see that I have a log base 6 of 4 plus log base 6 of 9. My bases are the same, so I look at my arguments, 4 and 9. I notice between these two logs, I have a plus sign, which means I can use that product property, which if I take my arguments, will say that I have 4 times 9. Well, simplifying that, making it into one single log, I have the log base 6 of 36. When I'm trying to evaluate that, I'm looking at, all right, well, 6 to some power has to get me 36, which is 2. Now, in my second question, I have a coefficient, right, in the front of my log. Now, what you see is that think about that power property. If I had a coefficient or that constant right in that front, that is technically the power of that argument. When you get 6 squared, you see, yeah, you got 36. Then when I bring down that log, base 3 of 4, I can see, all right, well, I have a subtraction. Subtraction means I gotta go ahead and use my quotient property, and I can put that log base 3, right? Bases are the same, but I could divide that 36 over 4, which gets me the log base 3 of 9. Well, trying to evaluate that, I can see 3 to some power has to get me 9, which is 2. Now, when I want to expand log expressions, my goal is to apply these properties to rewrite your expressions, kind of using as many logarithms as you can. Remember, expand means to kind of break it down, make it longer. So I'm going to use those power properties to turn any exponents that I might have into coefficients. So here we have two expressions here. I can see in the first question that I have 5 and x. So in that argument, they're being multiplied. So I know that that's going to be the product property. When I break it down, I'm going to have the addition of two logs. So I'm going to take the 5 and write log base 3 of 5. The second part of my argument, I'm going to take that x. I'm going to write log base 3 of x. Notice that I put the same base for both of the logarithms. Now in my second example, I've got log base 7 of 6 over y. So I see, oh, I have a division. So that tells me, oh, that's that quotient property. So when I expand and I write it out, I'm going to have a subtraction of 2 logs. So I'm going to take that 6 and I'm going to write log base 7 of 6. And then I'm going to take that y and write the log base 7 of y. Here you have log of 4x squared over y. You got a lot of different things here. So the first thing we should see is that in the numerator, I have 4 and then I have a times x and it's squared. So that's going to tell me that between that 4 and the x squared, I'm going to have the addition sign because that is my product property. So I'm going to take that 4 and write log of 4. And then I'm going to take that x squared and write log of x squared. What you should see is that you have a power, you have an exponent that's going to come right to the front and be a coefficient, which is going to get me 2 log of x. Now, for the denominator, you see that it's a division by y, so that means you're going to have a minus sign. So I'm going to write log of y at the end. In the next example, I have the natural log of the cube root of y. So now you need to kind of think back to your rational exponents and kind of think about that the cube root, when I rewrite it, is actually y to the 1/3 power. So that index of that 3 is going to become the denominator, and the y has an exponent of 1, so it's 1/3. Well, if I rewrite, I have the natural log, or ln, of y to the 1/3. Well, now I know that I have an exponent that can come right to the front and become a coefficient. So I have 1/3 natural log, or ln, of y. Now, when I want a condensed log expression, the goal is to use your properties to rewrite logarithmic expressions with addition and subtraction as a single log. So I want to make this smaller, right? Now, if a log is multiplied by a constant, so if that number was in the front, remember now it's going to become an exponent because of that power property. So let's look at some examples together. So here we have addition and subtraction between 3 logs in the first example. Now we want to make that into 1. So I can look at the first two and I see, all right, well, I have a plus sign. That means I'm going to use that product property. And the arguments, the 10 and the 4, are going to be multiplied together, which gets me 40. Now that you have a subtraction, know that your arguments are now going to be divided. So that simplifies to the log of 8. In example number 2, you look at the fact that you had a constant. So that 1/2 is technically the exponent on the argument of a. So that becomes ln a to the 1/2. Now, remember that anything to the 1/2 power, when I rewrite it as a radical, is technically the square root. So that really is the natural log of the square root of a. Now with that ln of 6, with the ln of the square root of a, you have a addition sign, which means that because it's addition, those two arguments are going to be multiplied together, which gets you ln 6 square roots of a. Now here are some things for you to remember. Always make sure that the base stays the same. So we don't want to change the base at all. And really understanding these properties of logarithms, the product, quotient, and power property, to help you to really expand and condense your logarithms. I hope this video was helpful for you and you're able to now evaluate and expand and condense logarithms using your properties of logs. Thanks for watching, and I hope to see you next time.